So in this video, I want to talk about Kmap simplification for 2 and 3 variables. Kmap simplification for 2 variables. Of course, the mean term function that we derive from our Kmap will not in the simplest term or simplest form yet. Okay, and that's what we start with in this example. We can, however, reduce our complicated expression to its simplest term by finding the adjacent one in the Kmap that can be collected into group, and that are the power of 2. Okay, so there's a few key important information we need to pay attention. Adjacent ones in the Kmap. Okay, and that can be collected into group, and that's the number of values one in that group gonna be a power of 2. Okay, power of 2 is mean can be a 0, be 1, 2, 4, 8, and so on. Okay, we can see show it through our example later on. So in our example, have the 2 such a group. Okay, so come back to the example of the f x y z equal to x plus y. As we discussed before in the previous lecture, we can see that the function can be represented in the Kmap in this form. Okay, so we can see right here with the condition of the condition of the finding adjacent one, and also that gonna be the number of one in the group gonna be about 2. So you can see that have the 2 such a group in this Kmap. Can you find it? I gotta give you a few seconds to identify the groups. Alright, I hope everyone gonna find the 2 group as identified and as shown at the bottom right here. So the best way of selecting 2 group of 1 from our simple Kmap is shown right here. We can see that both group are the power of 2, and also in this scenario we can see that it's gonna be overlap 2 groups. Okay, here the first group right here, you can see that that the 2 adjacent one right here. And also another one right here. This group also contain 2 adjacent one. Okay. The next slide is gonna show what the rules or what the guidance for selecting the Kmap groups. And here's the rules for selecting different group in a Kmap to for simplification. The first rule is saying that the group can contain only 1. Okay, there's no 0 in the group. Okay, so back in the example right here, this first group right here contains 2, 1, and the second group right here contains 2, 1. Okay, not the value of 0 right here cannot be combined or grouped into our group. Okay, so that's the first rule saying that group can contain only 1. Okay, no 0 are allowed. The second rule saying that group can be formed only at the right angles. Okay, diagonal group are not allowed. Okay, so back to the example right here, you can see this is a right angle right here, another right angle right here. We cannot combine in this way. Okay, that's a diagonal. It's not allowed in the Kmap simplification rules. Okay, so just can only be right angle allowed. The number of 1 in a group must be a power of 2. Okay, so even that contain a single values, that's a 1. So it means 2 power 0 equals 1, 2 power 2 equals 2, 2 power 1 equals 2, 2 power 2 equals 4, and so on. Okay, so the number of 1 in a group gonna be a 1, 2, 4, 8, and so on. Okay. The next rule is saying that the groups must be made as large as possible. Okay, so in case we can have a more than 1 possible groups, we're gonna select the largest one possible. Okay, so back to the example right here. For example, right here we can either group 1, have the two group, one, okay, one right here, one right here, or we can make a larger group right here. Let's combine two of them. So the rule saying that we need to make the largest one possible, and so in this case we have the two of them gonna be form the largest possible group, okay, instead of two separate one element group right here and right here, okay. The last rule saying that group can be overlapped and wrap around the side of the Kmap. Okay, so you can see two group right here. That's overlap. That's gonna be 5, and also we're gonna see another example. What is the wrap around side of the Kmap in our example in a few seconds. Okay, so basically that's a rule we need to learn and remember when we perform the Kmap simplification for different variables. So for the using Kmap for 3 variable is constructed as the shown at the diagram below. So basically we have the place of each min term in the cell that will hold its value. Okay, so here's the 3 variables. So basically x gonna be represented by this column with the input 0, 1, and y and z gonna be combined to be represented in the row right here. Okay. We should notice that the value of x and y combination at the top right here have the pattern that's not normal binary sequence. Okay, so we can see 0, 0, 0, 1, and 1, 1 instead of 1, 0. Okay, so gonna be 0, 1, 1, 1, and 1, 0. Okay, so that's the pattern for the y and z. And then we can see that a different min term gonna be represented in the cell right here. So the first min term right here corresponding to x equals 0, y equals 0, and z equals 0. Okay, so x naught, y naught, z naught, and so on. Okay, so the last term right here corresponding to x, y, and z naught. Okay, and so on. So you can see that different min term gonna be represented in different location or different cell of the Kmap. So from the representation we have before, you can see that the first row of the Kmap contains all the min term where x have the value of 0 right here. So the first row right here have all of the min term x equals 0. That's x naught, x naught, x naught right here. And the first column contains all min term where y and z both have the value of 0. Okay, so this value x, y equals 0 right here. So you can see the first column right here gonna have the x naught, y naught, z naught, y naught, z naught. Okay, x gonna be x naught or x corresponding to different row right here. Okay, so that's the first observation of the Kmap representation for 3 variables. Now, consider function f of x, y, z right here. You have the 3 variables, so we have the f of x, y, and z. Okay, so that's the typo is missing variable z right here. So the function can be represented by x naught, y naught, z, x naught, yz, and x, y naught, z, and x, y, z. Okay, so from the function right here, we're gonna represent this function using the Kmap. So basically, first of all, we're gonna need to represent the Kmap right here. And then based on the different term right here, gonna put the corresponding value of 1 in there. Okay, so the first term right here, x naught, y naught, z, x naught, y naught, z. Okay, so this first term we're gonna put 1 for each of the term right here. Okay, so the first term right here corresponding to this one. The second term right here, x naught, yz, so corresponding to the second one right here. X, y naught, z, x, y naught, z correspond to this one right here, and the last term corresponding to this one right here. Okay, so the first step we're gonna need to represent the Kmap, and then we can put or represent each of the term in the function right here corresponding to one variable 1 in the corresponding cell. Okay. So the next one we're gonna find out how to using the Kmap rules we just discussed before to group the variable one together. Okay. So based on the representation right here, what is the largest group of one that is a power of 2 we can have right here? Okay, so I hope everyone can find the same grouping I have right here. So this grouping tells us that the we can group all 4 of them together, so they satisfy the condition they are adjacent. That the number of elements right here, just 4, gonna be 2 power of 2, so that's gonna satisfy. And so the combination right here is just a right angle. Okay, so all of them gonna combine together. From the combination right here, we can see that the grouping tells us that the chain in the variable x and y have no influence upon the value of the function. Okay, or other hand, you can say that they are irrelevant to the output of the function. Okay, so you can see that grouping right here, the variable x gonna be 0, 1. Right here, and also the y gonna be 0 and 1 right here. So the first element right here gonna 0 and 1. Okay, so from the combination right here, we can see that if the variable gonna change value in this grouping, we can drop that we can drop that variable from the grouping and to simplify the function. Okay, so from this one you can see x gonna change from 0 1 right here, 0 to 1 right here, so x gonna be dropped. Y also change from 0 to 1 right here, so y gonna be dropped. So only z gonna be have the same value of 1 in this grouping, so we're gonna simplify this function right here, gonna be represented by f of x, y, and z. Sorry for the typo. So the function right here, again, this is a function right here, also have the typo. So the function f x y z gonna equal to z. So that's the simplified, the simplest form of this function. Okay, so or we can say that the Boolean function given at the beginning right here is equivalent with the simplified function f x y z equal to z. Okay. So to verify this reduction, we can use the truth table to see that the two Boolean functions, this function and this function, are equivalent. So if you using the truth table, you can see that actually they are equivalent or the same. Okay. Now consider more complicated Kmap. So consider the function k of f slash yz equal to x naught y naught z naught, x naught y naught z, x naught y z, x naught y z naught, x y naught z naught, and x y z naught. Okay, so basically that's the 3 variables. So we're gonna need to construct a Kmap of 3 variables right here, and then we're gonna fill the Kmap with the value 1 for each term represented the function right here. Okay, so for example, the first term right here, x naught y naught z naught gonna be corresponding to the value 1 in this cell right here. The second right here, x naught y naught z, x naught y naught z, so we have another one right here. So each term right here gonna be represented by a value 1, value 1 in the corresponding cell right here. Okay, and so on. You can see that here we have the 6 terms, so gonna be have the corresponding 6 values 1 in here. And then the last one right here, for example, the last one right here gonna x y z naught, x y z naught, so this is gonna be the last term right here. Okay, so once we represent all the term in the Kmap right here, we're gonna find the ways to group them together to simplify the function. Okay, So in this representation, we can see that there's a two and only two grouping of one we can have in order to simplify the function. So I give you a few seconds in order to find the group and give the simplification of the function. All right, so I hope everyone also have the same grouping we have. So we can see that here we have the two cat groups. So the first group right here can group all of the four one in the first row together, and the second group right here, as we discussed before, we can have the group can be wrapped around. Okay, so in this case we can wrap around right here, one right here group with another one right here. That's we call wrap around of the Kmap, the side of the Kmap. Okay, so from the first group right here, you can see that the value of x gonna equal to 0, and also the value of y and z gonna be changing. Okay, for example, y gonna change from 0 to 1, z gonna be changed from 0 to 1. So the first grouping right here, we can see that actually we can simplify into the value of x only. Okay, as we discussed before, if in one group the value of the variable changing, we can drop that from the simplify representation. Okay, or we can say that if the value of the variable changing, so it's not gonna be not impacting to the output of the function, so we can drop it. The second group right here, we also can see that the value of x gonna changing and only the value of z gonna not changing. So we can see that x and y in the wrapping group right here are gonna be not relevant to the term of the function that encompassed by the group. Okay, so from the discussion right here, we can see that the function can be simplified into a two-term only. Okay, so the first term right here, the green right here, can be a simplify into the x not. Okay, because y and z gonna be changing, so we can drop x and y, and this group right here corresponding to value x equals 0, so gonna be represented by the x naught. Okay, similarly we can see the second group right here, the value of x gonna changing from 0 to 1, so x gonna be dropped, and so y gonna also changing from 0 to 1, so y gonna be dropped, so the only value of z gonna not changing, z equal to 0 in this grouping. Okay, so this group gonna be represented by z naught. Okay, so that's the second term right here. So we can see that the function with the sixth term at the beginning, now we can reduce or simplify into two term only, such x naught or with z naught. Okay, so that's the function. That's a simplest representation of the function given at the beginning. Okay. To verify this simplification, we can use the choose table and compare the choose table of the two functions. Okay, so that's just the some brief idea how to use the Kmap for simplifying the Boolean function with three variables. The next video we're gonna discuss about the using Kmap for simplifying the four variables.